We could take a look on page 41. Okay, so how would you recognize that this is a combustion reaction?
CO2 and H2O.
You got CO2 and H2O as products, but you also have on the left-hand side, you have a hydrocarbon that also happens to have some N and some O, all right? And we also have O2, okay, as our two reactants. Now, if we count up everything, sometimes they get really crazy like this. So you need to say, okay, I have 5 O's because I've got a 3 and a 2. And on the right-hand side, because this particular compound contains nitrogen, I have carbon dioxide, water, and I also get NO2. All right, so I got 3 places, so I have 5 oxygen on both sides. Who should I balance first? In what order do we balance the reactions? C, H, O, and N we're just going to do before O because O is on its own. Okay, so we're going to leave O till the very last. So we'll throw in an N in there because O is a lone element. We'll do it last. So let's throw a 19 in front of our CO2. That gives us, updating, we have 19 C's, and 19 times 2 is 38, plus 1 plus 2, 38, 39, 40, 41. Now we have 41 oxygens. Well, that got crazy all of a sudden, didn't it? Yeah? All right, so carbon's good. Now let's do hydrogen. Oh, what do I notice about hydrogen? What kind of numbers do I have? I have an odd number and an even number. What do I do when I have an odd number and an even number? Crissy-crossy them, because what I want to do is I want to find the lowest common multiple. And the lowest common multiple of 2 and 17 is?
34.
34. All right. So once again, we're getting into crazy territory here. So we're going to put a 34 here. Oh, no, not a 34. I'm sorry. We're going to put a 17 over here on the right. And we're going to put a 2 on the left. So now we have 2 times 19 is 38 carbon. 2 times 17 is 34 hydrogen. I have 2 times N is 2 nitrogen. And 2 times 3 is 6. Plus 2 is 8. I can do math. Sure I can. So I have 8 oxygen over here. Wow. All right. Now I changed the H2O, so my hydrogens are now at 34. And oxygen, I now have 38 plus 17 plus 2. So 38 plus 17 plus 2 is 19. So 38 and 19 is 7. Carry the 1 is 57. Good gracious. I have 57 oxygens. And now I'm going to just move down a little bit and check and see if I've made any mistakes, because it is possible, right? So I've done these steps here. So let's just check. We've got 17, 19. Ah, there we go. So we are now at, that's where we were at. Who is unbalanced at this point? We have carbon is still unbalanced and oxygen is still unbalanced. Who should we balance? Oh, and nitrogen. Actually, everybody's unbalanced. Who should we balance next?
Carbon.
Carbon. Let's do carbon. Okay, so we're going to take our 2 and we're going to multiply 19 by 2. So that is 38. So now we have oh, did I do this wrong? Nope, I didn't. Okay, we're good. So now we have 38 carbon. And we have 38 times 2. So instead of 19 here, I've got 38 times 2. And I can't even do this without a calculator. So that's how sad it is. So 38 times 2 is 76 plus 17 plus 2 equals 95 oxygen. So my oxygen has become 95. Wow. Okay. Who should we balance next? Carbon's good. Hydrogen's good. We've got 34 and 34.
Oh.
Nope, not yet. O is last because it's a lone element. N is still unbalanced. So let's do N because if I just stick a 2 here, that's going to be easy. Okay, so now I have 2 N's and my N's are now good. And my O's, instead of 2 here, I have 2 times 2 is 4. So instead of 95 oxygen, I now have 97 oxygen. All right, let's see if I've done this correctly. Let's keep checking down here. 95, 97, there we go. So we've got 38, 38, 34, 34, 2, 2, and now I have 97 oxygen on the right and 8 oxygen on the left. Now remember, 6 of the oxygen I don't want to touch those, okay? So I have 6 oxygen and somehow or another, I need to have a certain number of oxygen plus 6 oxygen to equal to 97. Yes? So I have 6 plus something equals 97. What's the number there?
91.
91. How am I going to get 91 oxygens from an O2? 91 over 2. Whew. And then everyone will be good because this is going to be 97. What would we have to do now that we have that half in there? Multiply everything by 2. Okay, so we will have, let's see what happens here because I think I did it on the other page here. This should say 91. That's a typo. 2, 91, 38, 17, 2, and we multiply by 2 and we get this as our final. You will never on a quiz or test be asked to do anything near that nasty, okay? But what I would like you to do right now is I would like you to try balancing these combustion reactions to make sure that you're okay balancing combustion, okay? Some of them will be easy, some of them will be hard. Some will need halves, some will not need halves. Okay, so give them a try.
Did we do this yesterday?
Did you do pages 42 to 43?
Yeah.
Oh. Well, if you did those, did you do the Hebden for homework? Okay, grab yourself a Hebden. Anyone who's done 42 and 43, you can grab yourself a Hebden and you can do pages 110 to 111, numbers 1 to 20. Okay? Okay, so you're gonna go grab yourself a Hebden. It's on that bottom shelf there, and you're gonna use pages 110, 111, just 1 through. Okay. Yeah, it's fine. Of course. All right. You always pick up on everything, so I don't worry about it too much. I'm like, yeah, you're right. Call me over if you get stuck, okay?
Yeah. Wants to take that.
Yeah. Yeah, that's the other one. No, it's not. Always like. Yeah. Yeah, we have the back side, yeah. Let's see what we're gonna have then. Yeah, you found it. It's an alternate method of doing it, I don't want to vote because I found it. So it depends on what you prefer. Yeah. Okay, so
Okay. Yeah, you'll work with it. Okay. Yeah. Okay, so now you're gonna say how. You're not already. Okay. So this one. Yeah. Okay. And just one thing to notice with that one is you might have to reduce the lowest terms. Okay. If they're all divisible by 2 at the end, you need to reduce, but it is a good method. Okay. Okay. So you've got this, you got this, yes. And now you say, I have 7, and that's 7. So you have, this 2, there's 2 on both sides. Yeah. Oh, we need to make one. Yeah. Okay. Yeah. I'll send it. Yes. Yeah. Yeah. I'm comfortable. Because you need to keep it balanced. If you double one side, you're doubling the number of actions on one side. You're doubling the number on the other side. Okay. All of that. Okay. Oh, thank you. Like honestly, boxes and
White chocolate. There's like 6 of them.
Yeah.
I got them like 3 days ago.
Oh my God.
There's none.
Oh, yeah.
Is that okay? Yeah.
12. Okay. And then now, 3. And then you come up 4 plus.
You're right.
I need one. Well, there was nothing here. So there was something. It's not right. I look at things. I know you in terms of your thinking that you'll never have to work in the house, and you might need to reduce your. So if you want to try that, you can try that. So you start with 2 there. Yeah. That whole kind of. Yes, so this is all the like 4 days. Oh, okay. And then if everybody divides by 2, you go by 2. You might not be able to.
That will be done before you have it too.
Okay. But it's all. So keep the number, right? And divide it. And it's not. Right. You'll either end up with. Is it
Oh.
easier to do it that way when we're?
There's one on different pages, but they're not
Maybe.
same that.
What you like. Maybe the how to make more sense. That's just my version, right? Your body would be like, I know this. Your head, it's my brain, right?
Just like
Space. And you have.
What is your head?
The This is worse. Love is worse. And then like all this like that's not whole level.
That's either very hard.
Would you guys like to see another method as well?
Sure.
So you have choices? Okay. Because some people really like halves, but some people the half like throws their brain for a spin. So if you're finding the halves are causing you grief, here's another way to do it. Every time you get a combustion, start by putting a 2 in front of your hydrocarbon. Okay? Now, if you do that, you're still going to balance C and then H and then O, CHO. But you'll say, okay, I have 2 carbons, so I need to have 2 carbons. I have 2 times 4 is 8 hydrogens, so I need to have 8 hydrogens. How many oxygens do I have? I have 2 times 2 is 4. And 4 times 1 is 4, so that's 8 oxygens altogether. So I need to have 4 oxygens to give me 8 oxygens. So this is now balanced. And then you have to check and say, do I need to divide by 2? Okay, so that's the only extra step. So with this one, you put a 2 in front of the CXHYOZ, okay? Balance CHO. And then check to see if you need to divide by 2. And in this case, everything is divisible by 2, so you'll put a 1 and a 2 and a 1. Okay? Whoa. Our next example, if we put that 2 in front, now we have 2 times 2 is 4 carbons. Hydrogens, I have 2 times 6 is 12 hydrogens. So I need to have 6 hydrogens, or 6 times 2 is 12 hydrogens. And now for oxygens, I have 4 times 2 is 8, and 6 times 1 is 6. 8 plus 6 is 14. In order to get 14 O atoms, I need to have 7 O2 molecules. Do I divide by 2 here? No. So when you're doing it, when you put 2 in front of the hydrocarbon, you have to check and say, do I divide by 2 or do I not divide by 2? It's just like if you're using halves, sometimes you need to use halves and sometimes you don't need to use halves. Pick the method that you like best. They will both work perfectly well. Okay? Okay.
42, yeah. Okay. Yes. Oh, yeah. You're happy? Yeah. 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 Monday. Yeah. Yeah. Okay, well, it also could be the ramp. Let's make sure. Okay, so we have 2 times 2 is 4. 4. We have 2 times 4 is 8. So we have 8. Yes. And then we have 8 plus 8 is 60. So you have 8 there. And then all of these are divisible by 2. So you can tell us here by 2. Yeah. You should. Just write it out about. Like, no.
You even want to think it's
7 to 20, sorry. There is no question 1. 7 to 20.
Yeah.
Can I teach you guys a little bit more before the weekend? Yes. Okay. So we're going to go to page 55. Okay. And we're going to look at predicting products. So the trick with these ones is that you need to become good at recognizing that these are decomposition reactions just by looking at the reactants. Yes, you won't be given any products. These ones are obviously all decomposition because it's on a thing that says decomposition. But what do you notice about all of these reactants? There's just one compound. So the reactants for decomp, just one compound. And then what you're going to be doing is you're going to be saying, okay, I have just one compound. This is easy enough. I am going to break it down into the products, which are going to be 2 elements. Because what else can I do with a compound other than break it up into 2 elements? Did I tell you guys which page this is on? This is on page 55. 55. Yes. Yeah, for sure. Now, what you need to do is you need to look and you need to say, I have N and I have F. Those are my 2 elements. Do I have to do anything with those when they are in their elemental form? They are diatomic. So watch out for Brinkelhoff. And also, if you have sulfur, it's going to be S8, and phosphorus is going to be P4. You don't have to memorize these two. I'll put them on any quiz and test. I'll be like, watch out for S8 and P4, okay? But you do have to know the diatomics because they are just so, so common, okay? So you look at this and you say, I need to have N is one of the diatomics and F is one of the diatomics. So once I have that, then I just need to balance. So you go through and you say, oh, look, I need to have 2 N's. And that gives me 6 fluorine, which means I need a 3 here. The nice thing about these is that they're really easy to balance. Decomposition is really usually very straightforward to balance. Our next one, who are the 2 elements? Nickel and oxygen. So we're going to put nickel plus, separately, oxygen. And then I say, are there any diatomics?
Yes.
Yes. Who's a diatomic?
Oxygen.
Oxygen. So we put a 2 there. Oh, that means we need a 2 here to give us 2 oxygens. And that means I have 2 nickels, so I need to put a 2 here. Is that straightforward enough? Just split them up, look for diatomics, and then balance. That's it. Okay? So that's 6.3b. So that's going to be part of your homework. 6.3c. Synthesis. It's just backwards. So instead of having compound, what do you notice about the reactants here for synthesis?
It's always the diatomic.
Well, at least wise, it's always 2 elements. Yeah? So you're always going to have 2 elements. And all you have to do is put them together in a correct formula. So my question to you is the correct formula, when I put chlorine together with chlorine with Ag, Cl2Ag, is that the correct formula? No, what's wrong with it? There's 2 things wrong with it. Ag goes first because the metal always goes first. It doesn't matter what order we write the reactants. I could have written Ag plus Cl2, but you have to be okay flipping them around so that the metal goes first. And remember we had Cl2. Let's try it now. AgCl2. Is that good? Why not? Yeah, when you have an ionic compound, metal plus non-metal, you have to say Ag. You can look it up on your periodic table. It is +1. Cl is -1. So metal first, balance the charges. Okay, so we don't want AgCl2, we just want AgCl. And then finally, you will balance the equation. Okay, so we're going to look at this and we're going to say, I have 2 Cl's on the left, which means I need to have 2 Cl's on the right, which means I need to put a 2 in front of the Ag so that I also have 2 Ags. I didn't leave you a lot of room for making charts on this one, but because synthesis and decomposition are so straightforward to balance, you probably won't need it, okay? But feel free to use scrap paper to make a chart for yourself if you want to. So your homework is also going to include page 57 and 55, 56, 57. 55, 56, 57. Okay, make sure you do this. You've got a whole weekend to do it. Yes? And if you're finding like you've got too much to do, then do maybe every second question. You know what I mean? Right? So don't be like, oh, I'm just going to not do this or I'm not going to do that. Do every second question or do every third question if you can't manage the whole thing. Just make sure you're getting, although frankly for pages 42, 43, all the even questions are similar and all the odd questions are similar, so I wouldn't break them up that way.
That's right. Yeah. No worries. Yeah.